Hello, this is the task 3 that you need to design for the PWM. Okay, the task is develop the hardware and programming software for the application for analog input, LCD and DC motor control. Use a temperature sensor LM35 as a component input and LED, LCD and DC motor as a component output. For initial condition, display welcome, loading and then ready for display. Current temperature for LM35. Okay, the table shows the operation for the analog input temperature for 0 to 25, 0 degrees. Motor 1 is on by forward direction, so speed is 50% duty cycle, LED blinking, and then LCD display motor 1 forward. For the 26 until 50, motor 1 is forward direction, motor 2 is reverse direction. The duty cycle is 50% for each motor, and then LED 2 is blinking. Motor 1 forward and motor 2 reverse display at LCD. For the temperature 51 to 75, one motor reverse direction, second motor is the forward. Duty cycle is 100% for reverse motor 1, and then 50% for motor 2. LED 3 is blinking, and motor 1 reverse, motor 2 forward direction. Over than 76, motor 1 forward, second motor is reverse, 100% duty cycle for each motor, and then LED 4 is blinking. Motor 1 forward and motor 2 reverse display at LCD. So you need design, use Proteus software and then AVR Studio to develop programming software to simulate with the Proteus. Okay. For the circuit, we use the temperature sensor for the input. This oscilloscope to check the waveform for the duty cycle of the PWM. For the motor driver, we use L293 for to control direction and then speed of the motor, and then LCD we connect to port D. Alright, so the operation refer to the table. Okay, so if value below than 25, motor is off. Okay, and then for the value for 47 to motor forward, okay, forward direction with 150 duty cycle. That is 100 for the decimal value. Okay, this is the maximum speed of the motor. Is motor 1 and motor 2 forward 255. This is the decimal value to control speed of the motor. Right. So for the program, this one is the header file, and then this for the initialize for the ADC, and the second one is PWM control, and then we control the port input output for port B, port D and port C. And then for the main program, okay, we read temperature value and then install to temperature, and then we display to LCD, and we follow the table from temperature 0 to 20. Port C, all motor off. If 21 to 30, okay, motor 1 is running. Okay, and motor 2 also for 100%. This one 100 decimal value. Okay, this one for the 31 to 50. Okay, we set OC0, OC2, this for PWM control by 150. Right, this decimal value. Okay, the last one, if 80 to 150, 255 100% duty cycle for the PWM1 and PWM2. Okay, so motor 1 and motor 2 forward 255. Okay, that's all for the task 3. Thank you. Now I explain the hardware connection for the task. The first one, we connect LCD to port D. Okay, port D, and then for the IC driver we connect to port C. Okay, and then the temperature sensor LM35 we connect to the port ADC, port A. Okay, I use port A0. Okay, this one connection for the ADC. Right, so the temperature shows at the LCD, right? Temperature value, and then the motor 1 and motor 2 direction forward with the new with the value of PWM. Right, so now we hit the temperature. Now I using the solder iron, okay, to hit the temperature sensor, and then the temperature will growing up, right? Okay, the temperature is growing up, and we can see movement of the motor. Okay, forward to 100. 200 is the value of PWM. Right, so the value increasing because we hit the temperature sensor using the solder iron. Okay, the maximum value for LM35 is 150 degrees C. Right, so now increasing until 80, I think, for the maximum. Okay, increase the value. Okay, 255 is the maximum value. Okay, maximum value of the motor. Okay, and then the value decreasing. Okay, after I take out of the solder iron, and then speed of the motor decreasing, depends on the temperature value. Okay, that's all. Thank you.